Okay, this video is going to explain some of the more difficult concepts in chapter 12.1. It is not going to explain every vocabulary or concept that will be on the quiz. But let's get started with net force and balanced forces. A balanced force, is important to remember, is when there are two forces or multiple forces that are at work but combine to produce a net force of 0. That means if there is a balanced force, there is no movement. Okay, now let's see if you understand balanced forces. Which of these, A, B, or C, is an example of a balanced force? You should have found that C is an equal balanced force. The easy way to see that is because there's a net force of 0. We see that illustrated by the two arrows that are the exact same size, going in opposite directions, canceling each other out, creating a balanced net force that has no movement. In example A, we have the exact same force, but rather than going against each other, they are going in the same direction, which just produces a much stronger force going to the right. In B, we see an unequal force, a somewhat small force against a larger force, producing a smaller force going to the left. This force going to the left has absorbed part of this force going to the right, but it still continues to the left because it was always stronger or a larger force. C, again, shows that they are equal opposite forces that have balanced and canceled each other out, showing us a net balanced force. What we want to notice next is the difference between a static friction and sliding friction. The book explains that static friction is any force acting on any object that keeps it from moving. So in other words, this potted plant has static force which keeps it from moving. You and I, as the book says, experience static force every time we take a step. That static force keeps our feet moving forward and keeps us just from slipping and slipping. Now, let's take a look at the difference between static friction and sliding friction. In order to push this plant, we need to overcome the force of static friction, which is keeping this plant on the ground, not wanting to move. Now, when we begin to push this plant in this direction, static friction is now overcome, and we are experiencing sliding friction. Now, it's important to remember that static friction occurs when an object is at rest, whereas sliding friction occurs when an object is in motion. An object can only experience either static friction or sliding friction, but it will not experience both at the same time because an object will either be at rest or an object will be in motion. It cannot be both at rest and in motion. Now, the book spends several pages talking about gravity, but in this video we're going to focus on the more difficult aspect of gravity, which relates to projectile motion. Projectile motion basically is the idea that if an object is dropped in a vacuum, as we see here in example A, the green marble and the blue marble are falling at exactly the same speed, which remember is 9.8 meters per second squared. That's the acceleration of gravity, the exact same line when they're dropped from the same location. But what's interesting is that when you throw, for example, our yellow marble has been thrown, it's going to continue to be acted on by gravity at the same rate, showing us that it is falling at the exact same rate. That means if we imagine that a bullet is simply dropped in the path of this red marble, or if a bullet is fired in the path of the yellow marble, both bullets will reach the ground at exactly the same time. Obviously, the bullet that is dropped will reach the ground immediately below where it is dropped, and the bullet that is fired will reach the ground somewhere miles away from where it has been shot. However, both bullets will reach the ground at exactly the same time. This idea, this concept is called projectile motion.